So with that, I'm going to introduce our first speaker, Rodrigo Iturrieta. Rodrigo is from Chile as well. He studied at the Catholic University of Valparaiso, the Kyoto campus. He did both his undergraduate degree and his master's degree at that institution. I met Rodrigo when he was doing his master's in Chile, which he did actually on salinity and avocados. And in 2010, Rodrigo came to California to work at the University of California. And subsequently, during that period of time, he did a PhD, and he's going to cover a lot of what he did for his PhD research today in his presentation. And then he has continued working at UC, sort of continuing his vision of trying to understand how avocado trees grow and tree architecture. In my research group, we have put a lot of focus on tree architecture, and that's a main focus of what we're doing now. What are the genes that are controlling the shape of the tree, and or how can we manipulate the tree to be the shape that we want it to be in? And so he is going to give a presentation now on how shoot growth influences fruiting and light distribution.
Thanks, Marilu. Let me share my screen. There. Hi, everybody. Good morning and good evening. I hope this is interesting. There's some data, but there's always some picture of how it looks in the field. So you know what I mean as I go. The title of my presentation is how the relationship between shoot growth, fruit, and light. But all this comes really from my research, as Marilu said. My research was about alternate bearing, the problem of it. And one thing that bothered me when I went into this subject is that I couldn't find an actual model what is alternate bearing, how does it work. So I went into that search basically of what I can find, and to me the stuff on the left, this fancy thing on the left, is what I truly think alternate bearing is. How does it happen? But all this stuff came from looking at the trees, and that's what I mean. That's what we're going to talk about today. How shoots behave in reference to fruit presence, and that is alternate bearing. Truly, that's how it looks. This is how it's explained. So we're going to focus on the visual. In order to do that, I decided to switch a little bit my observation, my point of view, from the whole tree to the unit that has fruits, has vegetative growth, and has reproductive growth on the same structure, and that's a shoot. It's as simple as that. What comes out of a bud, an axillary bud, an apical bud, is just the shoot structure. That's the one that may or may not have fruit. So I focus on that. And once I did that, a whole world was shown by the trees to me. Sections within a shoot, things that happen, flushes, branching patterns. And that allowed me to compare, fruit presence, and also see this in different countries. But when you go fancy like this, it's not always very informative. There's a balance between what works in the labs and what's useful for the research, and also what you can do in the fields quickly and reliably. So this whole thing became the simplistic approach. I call it topography. I just want to convey the idea of a shoot has sections and they have certain shapes, and that's what I call topography of a shoot. On the left, you have a very simple shoot. It's just a single flush. Imagine every time you see a color, it's just a flush. Some people call them spring, summer. I call them first, second, third. That's all. I don't want to give them a date. No. So one flush simple means one single flush of a shoot, no branching. One flush with branches, two or more flushes, no branching, two or more flushes with branching. So that's the whole language and visual language I'm going to use from now on. It could be very complicated, but this is what you see in the fields. It's useful. So when you have a fruit has trees. 70% of the time, the shoots are simple. Just like in this picture on the right, the fruit is hanging. The shoot itself that bear that fruit is just a single flush, no branching. So that's, if you grab a fruit on a canopy of has, that's probably you're gonna find that. That's the whole vegetative growth you're gonna get. And that looks like, as I said, this is in Riverside, it's the same story. As in Chile, it's the same story. You know, one fruit hanging, one simple flash of growth. Israel, the same thing. Peru, and it's not just has, avocados do this. And South Africa is the same theme. And it doesn't matter really if you have 1, 2, 3 or more fruits. It tends to be a very simple, one flush, no branching, repetitive pattern of growth. Something that goes along with that, of course, we just saw this, 70%, one vegetative flush. And if you only get very few times, 8.5% of the time, 8% of the time, you get a lateral. So it's very unlikely that a fruiting shoot will give you more than one flush and laterals at all. That's what you just see looking at many, many shoots and many, many has canopies. It was useful to compare, make this chart, California versus Chile versus South Africa. Long story short, everybody's doing the same, which is what I did, what I just explained. When you have a fruit, you're very simple. Blue is simple. When you don't have fruits, your vegetative growth, your shoots are more complex. They have more branches, they have more flushes. So the same thing in Chile, the same thing in South Africa. And this is just that because I had data. But I also saw this in the countries I show you, Israel, Peru, all the same behavior in reference to fruit presence. So I was mentioning when you have no fruits, you usually have branching. Where is that branching? If a shoot is a unit you can follow and it has certain shapes and positions, where are the laterals? Where do they come from? So I made this map basically of a average has shoot with no fruits. So that's why it has more flushes here. And this chart only is about to tell you the likelihood of observing a lateral coming out on that bud, on that axillary bud, on that axillary bud. So you see that it's dropping towards the base of a flush, or said in reverse, you're likely to see a lateral near the end of a flush. Turns out is usually like the 8% independently of the length, the very tip, the very end of a flush is where you find laterals. So if you go back in time, you see that also in the previous flush, the higher likelihood was towards the end of it. And even to the very first one, if you're gonna see some laterals, it's gonna be towards the end of it. And how does that look in the field? A picture of it. That's it. This is has. Colors are flushes. First flush, second flush, third flush, and this is the transition. Right below transitions, you have a lateral here, a short lateral there. Right below transition, a lateral that way. So it's simple as that. That's the chart about. This is how it has non-fruiting looks like. And that's the position of the laterals. So has is very empty in between the flush, within the flush, until the very end where it does this. Empty, lateral. Empty in terms of laterals, and it just keeps going. So I know there was a discussion about Maluma with Sander the previous cafe. So I brought that comparison of has versus Maluma. There's no difference in terms of the big overall behavior. Fruiting has is simple, non-fruiting has is complex. Maluma fruiting is also simple, and Maluma non-fruiting is complex also. So there's no difference there between these two varieties. So what is the difference? The difference is at the location of this branching. So you'll see now. We just saw this picture. Has does the lateral branching right below transitions. That's the brown, diagrammatic here, representing a lateral. Maluma has the brown ones, the regular laterals, but also has these green ones as I draw them here. And their position in the places where has usually has nothing, where it has is simple, is where is Maluma is doing something different. It's growing differently. So how does that look in terms of a picture? It's just this. I mean, you saw the has picture, it had different colors. This is a really long first flush. I didn't even capture the second flush yet over here. And you see how this forking of the shoot epimeristem is just separating itself as it's going. The shoot epimeristem, the shoot tip is going this way. The laterals are just breaking to the sides as it's also growing in length. So this type of growth is called syleptic, but it's just concurrent. As the shoot tip is growing, you have laterals being late, released. That's just elliptic. Maluma is doing that way more than has. You can see it in has, but the likelihood is less. So the difference between has and Maluma was in this case the position of these laterals. So, okay, when there's a fruit, they do the same, but when there's no fruit, they just grow more laterals. And bear in mind, these look like spurs. I mean, this behavior is short growth along the flush. It's like spurs in apple, that reminiscent of that. So let's bring the issue of trellis, because as you can see, there's a wire there. And that's in South Africa. So it was trellis. So it was all about fruits versus lack of fruit, but what about having Maluma in this case evaluated on regular cultivation self-standing trees versus the same variety on trellis? Did something happen? Let's ask the same question. Fruit, no fruit, what happens? And the fruit sections with fruit section is here. The data without fruit is on the right. So if we focus on shoots that have fruit, which is this side of the chart, Maluma on self-standing, you see is simple. The blue bar is just a lot of simple shoots, nothing special. Everybody does that. Maluma with fruits on trellis, the blue got reduced, the yellow showed up. And always in my language, the yellow ones is more complex. Yellow is more branching, more flushes. So there you go with fruits. They just behave so differently just by being on the wire. More branching, more flushes. What about the lack of fruit? It's nothing special that when there's no fruit on a shoot, it's more complex, but on the trellis, it's just so many more chances of having more complexity and more flushes along the wire. So that was just the data I was observing in these trees, the effects of having the same variety on a wire growing. In terms of lateral branching, that's just the number, the likelihood of having a has versus Maluma in terms of branching. 8% of the time we saw this before, but Maluma with fruit on the wire, 20% chances of having laterals. So that is an increase in vegetative complexity, that there's more growth and more laterals within. So yeah, even on fruiting shoots. So does it matter? Can you make that happen in has? Is something that we can control? If I'm saying here to you that more complexity is better, can we do something about it? So the answer for the has, because I'm showing Maluma, is that you're able to do this. You can alter how a fruiting shoot looks in has, which should have been very simple. No branching, with sunlight exposure, and they look like this now. So the colors are flushes, and the lateral branching, you can see, is still right below the transition. Right at the end of it, right below is where you find the laterals. But you have many more flushes and many more laterals than you would have if this fruiting shoot was not sunlit. So sunlight penetration is something that can alter a fruiting shoot and show you what a non-fruiting shoot looks like, despite also bearing the fruit that you can harvest later. So in a diagram, this is what it looks like. A fruiting shoot usually is simple. A non-fruiting shoot is usually longer, more flushes and branching. But if you force sunlight exposure, let's say by trellising or a good strategy in pruning, you are gonna change that fruiting shoot. And that's gonna increase complexity of those fruiting shoots also. Why do you want complexity? Why I keep talking about that? Well, it's all about the flowers. It's about the business. Flowers is, how you get fruits, and that's the ones we sell. So complexity does this later. A fruiting shoot that is not complex, you only have a chance of having, I'll show you the data right after this, but the likelihood of seeing an inflorescence in a fruiting shoot is very small. And if so, it's at the very tip. The chances of having flowers at the non-fruiting shoot within a canopy is always higher at the tip, but you have more likelihood in the buds below the tip as you're going down into the flush. And right below transitions, you have the laterals, and laterals have their own shoot tips, and the likelihood is higher there. Another tip, the main tip. In this case, you only have one tip, and that's it. And I'm mentioning tips because the likelihood of having flowers there is just higher. But you also can see that I draw inflorescences along the flush, and that's something also you don't get much on a fruiting one. So in terms of numbers, just think of this as the shoot tip of a non-fruiting shoot, the shoot tip of a shoot that has a fruit growing, and look at the tip. 64% of the time, I saw inflorescences in there, in that shoot tip, and 54% of the time along the flush. If you just focus on a fruiting shoot tip, 61% of the time, the similar percentage, but it's just the opposite. 60% of the time you find leaves. There's no flowers in there. And same as here. It's almost flipped, but the fate of those axillary buds and the shoot apical meristem, the shoot tip, is just not reproductive. It's just vegetative. Vegetative is default. You need to change vegetative to flowers. They just don't change because you have a fruit there. So that's why I was drawing this. This is the visual version of the previous thing. That is just the numbers, but more complexity gives you more chances of having tips and buds below with inflorescences within. So let's go back to trellis as an example of, sunlight exposure manipulation in a way. Okay, you have more complexity, you get more fruit. I mean, that's the bigger deal. It's this convenient in a way. Of course, I'm not an economist. I will just show you the data, what the trees showed me. And here it goes. We saw this before. This is a has, but it's just an example of a one shoot, one fruit hanging in there. 80% of the time has does this. I mean, one fruit per shoot. Maluma, 90% of the time, is also just one fruit per shoot. Maluma and trellis, 75% of the time, I saw one fruit per shoot. This is all about how many fruits are hanging on a shoot. One. Everybody does one. Well, let's make that a little higher. How many shoots have two fruits hanging until maturity? Has 12% of the time you will find this picture. Maluma, 10% of the time you in the traditional self-standing production, you will see this. So it's even less than has. Maluma and trellis, it just explodes. The chances of having two fruits on the same shoot growing is just twice as high. So you're more likely to get this picture that Sander, our previous speaker, took these pictures. On the wire, on a trellis, you just get two fruits per shoot more frequently. And big ones. I mean, this is not a big one and a small one. This is just two regular fruits hanging on a single shoot. It's just way more likely to occur. So I went from what a fruiting shoot looks like, because that was alternate bearing. I was looking for what the fruits do to a shoot. And then you see that your database is showing you, the trees are telling you, if I have sunlight, I'm going to do something different. I'm going to be more complex. And that's the trick. That's the importance of sunlight, penetration into the canopy. You will change the shape of the shoots, and they will give you more flowers, potentially more flowers the next season, even if they're fruiting this season. So I want to switch a little bit to I'm going to look at the canopy again, a little further away, because we've been looking at shoots. Let's talk a bit about the sunlight response in the field, I mean, in the canopy context. So imagine, well, just look at this. I mean, these are two hass trees right here on Riverside. This one is smaller because it was sick and we severely pruned it. And this one is probably the largest tree I had. This was some of the trees I did my research on. But my point was the following: how do you get this very widespread canopy? Why so open, wide, compared to, you know, what this looks like now, which is more round and contained? So when I introduce you to these guys are what I call spirals, but if you put it lower in the canopy, this will be a water shoot, you know, the suckers that you get rid of. But my point here, this is a very vigorous growth. And if you look at it, you'll see that on the left, there's much more branching than on the right. Despite the vigor, they just don't have laterals here. So what's the difference? Well, sunlight is on the left. This is the outer canopy section of this shoot. And on this section, they're towards the canopy, towards the shade, towards the trunk. And avocados, in general, they just don't grow too much. They don't even release buds into growth, even as they're growing, you know, really long and vigorously. They're just not going to release. There's like some control system there. Just don't waste energy into the shade. So if I put this back in this canopy, just as an exercise, that's what it looks like. You're bound to find this branching this way. And what happens with this branching bias towards the sunlight, that later on, they're going to open because heavy. They have branches, even if they have fruit, they just bend downwards because there was no growth towards the inside. And now you bent out of the way. Now you're getting sunburn here because hass doesn't do what Maluma does. Doesn't have the spur-like growth that's going to help you with sunburning. And it's weak enough that it's just going to bend because of the branching bias. And you're going to have fruit here hanging. You're going to get a sunburn here, and you're going to get wide, just like the one on the left. That's how it happens through time. So I wanted to share that sunlight exposure in vigorous growth that can form a structure that can fill a whole quadrant of your canopy. Those are the spirals. Those are the water shoots, in a way. They have this branching bias, and branching bias will affect the shape. And I wanted to show you that you can probably modify, we'll hear with Gerardo about it, modify that through the penetration of light towards this system, the canopy system. So as a bit of a summary, and going back to my own research, this is alternate bearing. This is what trees do. Nobody is always spoken in general terms, but fruiting shoots, they just don't contribute the next season. The likelihood of flowers and the complexity of it is so low that what gave you fruit this season is not going to give it to you like next season. Actually, 20% of the time, they just die. They give you fruit, and then that growth doesn't go anymore. There's no next year season growth here and here. While the non-fruiting ones, they just outgrow the fruiting ones. The fruiting ones remain inside the canopy. The other ones grow so long that they make them to be inside the canopy. It's something, everybody starts together, but the ones that set fruit, just remain simple, and the other ones just keep growing longer and more complex, and they become the outer canopy, while the fruiting ones get to remain inside, and we just have to dig into, stretch our hands and grab the fruit inside the canopy. This is how it happens. And that's why when you have too many of these units in your canopy, you have an on year, you have a lot of this, and next year, a lot of that. The shading that the complex trees do, the complex shoots do as the season progresses, just keeps these guys shaded and enabled to be recuperated by light penetration. So that's the tricky, that's the dynamic within a shoot. And if you think of a shoot as the unit that can be repeated, and it's basically, we call it canopy later. You know, if you add some soil and you add some sunlight, some sky and some other trees, you understand that what shoots do is what we end up seeing as the canopy behavior. And the fruiting ones are going to remain towards the inside because the other ones, non-fruiting, just outgrew them. And the flowers are going to be here next season, not in the ones that were fruiting, because that's done. Unless we get some increased chances by manipulation. Gerardo's going to show us the way to do it. It's a process we need to go through in the avocado industry. It's not like you don't need to jump immediately into trellising. It will give you the effect I show you. The trees will just grow more complex, and more complex means more flowers, and you have two fruits instead of one fruit hanging on a single shoot. But there's a process we need to go through. Not all varieties will adapt to this. I wouldn't advise. It just has this emptiness in between that Maluma doesn't. You see how full of spur-like growth is this. So there's a balance between rootstocks, as Marilu was saying. To me, most important, even more important than that, the behavior of the variety that will accommodate this better than others. So you can have self-standing trees in the slopes of a Chilean production or high slopes of California. You have maybe trellising or pergolas, other control of sunlight penetration at the flatland, but we need to do the process. We need the varieties, we need the rootstocks that do accommodate this. So growers do less, varieties do more for them, but this is what we need. Branching patterns at the shoot level, accommodating potentially different ways to approach cultivation and harvest, and fruit counts will be easier later, but we have to do the process. And well, I'll stop there, and we need to hear Gerardo because he's gonna make this whole thing together. This was shoot level and information, just need to be also practical, and we're gonna learn from him about it. Thank you, guys.